Here we discuss the solution of an important problem of central orbit. Now the problem is a particle of mass m moves under the central force m mu into 3a by r to the power 4 minus 2 into a square minus b square by r to the power 5, where a greater than b, and is projected at right angle to the radius vector at a distance a plus b. Okay, and this line may be of this type projected from an apse at a distance a plus b. These two are the same meaning. Okay, with velocity root mu by a plus b, so that the orbit is r, this is equal to a plus b cos theta. We have to prove the orbit or the central orbit is this type. Here we first write the central force per unit mass. Central force per unit mass is P, this is equal to mu into 3a u to the power 4 minus 2 into a square minus b square into u to the power 5, because r, this is equal to 1 by e, and this is named as 1. Okay, now we write the differential equation of central orbit in polar form. Okay, differential equation is, this is equal to h square into u plus d2u by d theta 2. This is equal to capital P by u square. And now put the value of p square here and get the result as mu into 3a u square minus 2 into a square minus b square into u cube. We cancel out u square and u square. Okay, and this is named as equation number 2. Now we multiply both sides by 2 into du d theta, that is 2 into du d theta into h square into u plus d2u d theta 2. This is equal to mu 2 mu into 3a into u square du d theta minus 2 into a square minus b square into u cube du d theta. Okay, now integrating this result, we get h square into, this is u square plus du d theta whole square. This is equal to 2 mu into a u cube, because the integration of u square is u cube by 3 and 3 cancel out, minus this is a square minus b square into u to the power 4 by 2. This is named as equation number 3. Sorry, there be another integrating constant, let it be c1. This is number 3. Now from the given condition, here given condition that projected at an angle, at a right angle to the radius vector. So we know that the angle of projection is phi, that is the angle between the radius vector and the tangent. Okay, and we know that P, this is equal to r sin phi, sorry, P, this is equal to r sin phi, that is here P, this is equal to r sin pi by 2, because this is right angle, so phi is pi by 2, so P, this is equal to r. When we project from the point where the angle of projection is phi, then P, what is P? If we draw a rough sketch of the central orbit, then we get, this is the tangent and this is P. Okay, this is P and this is phi, and this is R, this is O, x and P are theta. This is theta, and this is the angle of projection because velocity act always along the tangent. Now we get P, this is equal to R. P, this is equal to R, that is P and R coincide. And when P, this is equal to R, then that point is said to be apse. Okay, apse of the orbit. So we say here projected from an apse at a distance. So at an apse, so these two languages are same meaning. And here it is said that at a distance A plus B, or also here distance A plus B. So we get P, this is equal to R, this is equal to A plus B at the point of projection. Now from the differential calculus, we know the result from this relation 1 by P square. This is equal to 1 by R square plus 1 by R to the power 4 into dr d theta. We know this result, and since R this is equal to 1 by U, so dr by d theta, this is equal to minus 1 by U square into du by d theta, and putting this value of dr d theta and R in this result, we get 1 by P square. This is equal to U square plus du d theta whole square. Right? Now we put P, this is equal to R, that is 1 by P square, this is equal to 1 by R square. So U square plus du d theta, that is U square, this is equal to U square plus du d theta whole square. Sorry, and that is du d theta, this is equal to 0. So at the point of projection where the angle is right angle or at an apse, du d theta must be 0. Now we put the result, all result. Here the first result is du d theta is 0. Second result is velocity is this. So v square, this is equal to mu by a plus b whole square. Right? And distance r, this is equal to a plus b, that is u, this is equal to 1 by a plus b. We put all this result here. So we know that in central orbit the expression of velocity, this is v square, is equal to h square into u square plus du d theta whole square. Okay, this is named as equation number 4. Now we put the value of v square in this relation, that is the relation 3, and we get 3 becomes v square, this is equal to 2 mu into a u cube minus a square minus b square into u to the power 4 by 2 plus c1. This is named as relation number, sorry, this is 5. Now we put all the value. Okay, we cannot put all the value here because here h square present. Now we eliminate h square by this two relation, we get this result. And putting the value of v square, this is equal to mu by a plus b whole square. This is the velocity expression, and 2 mu into a by u square means 1 by a plus b whole square, that is a plus b whole square minus a square minus b square by 2 into a plus b whole to the power 4 plus c1. Calculating this result as 2 mu by a plus b whole to the power 4, taking common, and also we take common by 2, and this is 2a into a plus b minus a square minus b square plus c1, and this gives 2 mu, sorry, this is equal to 2 mu by 2 into 2 to cancel out, a plus b whole to the power 4, and this is 2a square plus 2ab minus a square plus b square plus c1, and we get c1. This is equal to, the left side is mu by a plus b whole square, and the right side becomes minus mu by a plus b whole to the power 4 into this is 2a square minus a square, this is a square plus 2ab plus b square. So this is a plus b whole square. Clearly the value of c1, this is equal to 0. Also putting the value of initial condition in relation number 4, in this relation we get mu by a plus b whole square, this is equal to h square into 1 plus a plus beta whole square plus 0, because du d theta, this is equal to 0 initially, and we get the result as h square, this is equal to mu. Clear? So we get two results from 3 or from 4 and 5. These are, first result is c1, this is equal to 0, and the second result is h square, this is equal to mu. Okay. Now we put these two results in equation number 3. From 3 we put h square, this is equal to mu, this is mu into u square plus du d theta whole square, this is equal to 2 mu a u cube minus a square minus b square into u to the power 4 by 2 plus 0, because h square, this is equal to mu, and c1, this is equal to 0. We already get two relations, and we cancel out mu from both sides. This is the relation. Now here we substitute u, this is equal to 1 by r. Okay, and du d theta, this is equal to minus 1 by r square into dr d theta. These two results substituted here and get as, this is 1 by r square plus this is 1 by r to the power 4 dr d theta whole square, this is equal to 2 into a by r cube minus a square minus b square by r to the power 4, and 2 cancel out, right? And we cancel out from both sides the value of r square, or r square from both sides. We get the result as 1 plus 1 by r square dr d theta whole square, this is equal to 2a by r minus a square minus b square by r square. Now by taking LCM we get, this is r square plus dr d theta whole square, this is equal to 2ar minus a square plus b square, and changing the side of r square we get dr d theta whole square, this is equal to minus r square plus 2ab minus 2ar minus a square plus b square, and clearly this is b square minus r minus a whole square. Okay, b square minus r minus a whole square, and taking square root from both sides we get dr d theta, this is equal to plus minus root under b square minus r minus a whole square. Now this is the final differential equation of central orbit, and this is ready for integration. Now we get dr by root b square minus r minus a whole square, we take this side plus minus, this is equal to d theta, and integrating both sides, here be another constant. This is said to be C2. This is integrating constant. Now the integrating this side we get, this is plus minus or minus plus cos inverse r minus a by b. This is equal to theta plus c. Okay, now this is the final result. Now to eliminate or to determine the arbitrary constant or integrating constant, we take initial condition. We take initial condition such that C2 समान 0. Okay, we take here the initial condition such that C2 is equal to 0. Then the equation becomes minus plus cos inverse r minus a by b. This is equal to theta, and cos inverse r minus a by b, this is equal to plus minus theta. So we get r minus a by b, this is equal to cos plus minus theta. This means cos theta. So our final result or the curve or the central orbit is given by r, this is equal to a plus b cos theta.